Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear? Whether the screen is visible or not, right?
Yes, sir.
So in the yesterday's session, just I was briefing you about big data, Hadoop and Spark, advantages, drawbacks with the current databases, Hadoop components and Hadoop Spark and job market. Fine. So Hadoop is meant for storage and for processing. So Hadoop is meant for batch applications, means user non-interactive applications, and it is not for online applications. So online applications means user has to give the input, right? But what all the applications like batch applications, right? We go for Hadoop. Means where user is nowhere required. Means like credit card statement generation, financial applications, railway ticketing, right? These things. Drawbacks with the databases is limited storage, no parallel processing in most of the databases. As volume increases, speed decreases in database. If complexity increases, speed decreasing. Databases, the major drawback is it can handle only structured data. They cannot handle unstructured or semi-structured data. Yes. So very high speed processing, right? If you can just check this, unlimited data storage is possible because of horizontally unlimited scalability. Very high speed processing because of parallel processing can handle all varieties of data. It's an open source, no licensing required. Commodity hardware, right? Yes. Means highly configured hardware configuration is not required. It can run on any hardware, right? So why databases cannot support unlimited storage means there is a limit on the databases. Maximum they can go with 256 systems or nodes, right? Or 512 or 1024 max. Specialized databases like Teradata or Netezza, Vertica, they can go with max. But there is no limit on the number of nodes that Hadoop can have, right? Yahoo, when first time implemented Hadoop, went with 4,000, currently going with 12,000. Facebook, when first time implemented Hadoop, 8,000 slaves, now currently going with 42,000 systems. So there is no limit. Storage point of view, it is proven in the market. Even processing point of view, right? It is proven in the market. So it has Yahoo has taken a table of 100 TB consisting of 1024 columns, sorting based on 16 columns. Time taken, right? Time taken, right? What is the time taken by different databases, right? Like Oracle has taken 3.5 days. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netezza has taken 3 hours to sort 16. So to sorting 16 columns in order based on 16 columns. Sorting based on 16 columns. Generally, you will sort by based on a single sorting based on age, sorting based on rank, but sorting based on 16 columns. Hadoop has taken just 4.3 minutes. Latest version of Hadoop has taken 2.4 minutes, right? Yes. Fine. So Hadoop follows master and slave, single master, multiple slaves, single master, multiple slaves. So connection group of computers connected in a network. We call this as a cluster. One master node, multiple slave nodes. So in this master node, we have got name node. Within this slave nodes, we have got data node. Data node 1, slave 1, slave 2, slave 3 means system 1, system 2, and system 3. Data node 2. Data node 3. In this, okay, storage point of view, First, if any file comes to it, f1.txt file, when it comes to it, it divides that f1.txt file into smaller parts. Each part is stored in one system. And are processed parallelly. That's why we can say distributed storage and parallel processing, right? So name node doesn't store any data. It will just maintain the metadata. Name node just metadata information. Data nodes are responsible for storing the data, right? And for processing, we have got job tracker and task trackers. Task tracker 1, task tracker 2, task tracker 3. So here the data which is divided into fixed size, we say blocks, B1 block, B2 block, B3 block. B1 stored here, B2 stored here, B3 stored here. Three blocks are executed by three task trackers, task tracker 1, task tracker 2, and task tracker 3. Parallelly they are executed. Yes. So in the master node, we have got a name node and job tracker. In the data node, we have got data node and task tracker. Yes. Okay. So this is what Hadoop cluster group of CPUs contain master and slave nodes. Within the master node, name node and job tracker, one is for storage, one is for processing. And within the slave nodes systems, right? Data node and task trackers. Task trackers are responsible for executing the task. Data node is responsible for storing the data. Yes. So here you need to within the master and slaves, right? Within the master and slaves, in the master node and slave node. Job tracker within the master, task tracker 1, task tracker 2, task tracker 3. Hadoop follows master and slave within this job tracker. Task tracker 2, 3, right? Job tracker assigns T1 task to T2 task to this T3 task. Three tasks are executed by the three task trackers parallelly. Means if you've got a 40 node cluster, 40 tasks can execute parallelly by 40 systems, 40 task trackers. So number of task trackers equal to number of task trackers equal to number of systems, number of slaves. The system slave 1, slave 2, slave 3. Means system 1, system 2, system 3, right? Number of task trackers equal to number of slaves. So here we need to understand some more things, right? Yes. So how a file, okay. Just observe this. What do you mean by speculative execution? What do you mean by speculative execution in Hadoop? What do you mean by speculative job? What do you mean by speculative task? Speculative execution, speculative job, and speculative task. So speculative execution, to understand, first you need to understand this, right? So within the master, we have got a job tracker within the slave systems. So Hadoop follows master and slave, single master and multiple slaves. Within the slaves, we've got task trackers available. So job tracker assigns tasks, task trackers has to execute the tasks. So first, what do you mean by speculative execution? Speculative execution, right? Yes. Job tracker assigns. Job tracker assigns. Job tracker assigns tasks to task trackers. Task tracker, see, this task tracker has to task tracker has to respond within the given time, called as heartbeat time. Job tracker assigns tasks to task tracker. Task tracker has to respond to job tracker. J team is job tracker within the given time, called as heartbeat. Called as heartbeat time. If task tracker is not responding, if task tracker is not responding, observe this, is not responding within the given time, then job tracker assigns another task tracker. This process is called as speculative execution. This process is called as speculative execution.
Sorry, here you are talking about execution or just assigning the task to the slave?
So here, execution, if task tracker is not see here, observe this. What happening internally, right? Which we won't be able to see these things. Master and slave. These are the master and slave, right? General. Observe these things. Master and slave architecture. f1.txt. So here within the master node, name node for storage, job tracker for processing. Within the slave nodes, data node 1, data node 2, and data node 3. Task tracker 1, task tracker 2, task tracker 3. So this name node and this data nodes are responsible for storage related. Name node divides this file into blocks. So this name node, the file will be divided into blocks. B1, B2, so on, right? Bn. B1 block stored in this one, assume. B2 stored in this, assume. Some Bn is stored in this. Blocks are distributed. Blocks are distributed, right? Yes. Means B1 has got 10 lakh records. B2 has got 10 lakh in this way. B1 has got 10 lakh. B2 has got 10 lakh. Yes. Executing this B1 10 lakh is nothing but now job tracker, what it does, job tracker number, okay. How many blocks for B1? Executing this B1 is nothing but T1 task. Executing this B2, T2 task. This is Tn task. So job tracker assigns T1 task to slave this only because B1 block is present in this system. Only this system only can execute this T1 task. T2 task is nothing but executing this B2 means only like this particular system only can execute this T2 task as B2 block is present here. T3 task is assigned to this. So T1 task, T2 task, T3 task. Who is assigning? Job tracker. To whom it is assigning? To the task trackers. Who executes the task? Task trackers. Who assigns the task? Job tracker. Once this task tracker completes executing this T1 task, it gives acknowledge to job tracker saying that, okay, the job is completed. Once the job is completed, job tracker assigns if any tasks are in the waiting state, that task will be assigned to this task tracker 1. So after task getting executed, acknowledgement is sent. Acknowledgement is sent to job tracker. So for every 2 seconds, right, there will be heartbeat signals between job tracker and task trackers. If suddenly if any system goes down, then immediately job tracker assigns that task T2 to any of the other slave. How job tracker, you may ask, how job tracker comes to know that this particular system is down? Heartbeat signals between the job tracker and this task tracker. If the heartbeat signals are missing, immediately job tracker thinks that system is down. Immediately it is assigned this T2 task to the any of the others. Third process we call it as fault tolerance. Means if any system fails, then the task of that system assigning to any of the other system, right? And that is what we call fault tolerance. So here I'm talking about the job tracker and task tracker. Job tracker and task trackers, right? Yes. Job tracker assigned T1 task to task tracker. Task tracker has to respond within the given time to job tracker. That what we call heartbeat time. But if task tracker is not responding within the given time, job tracker assigns that if this task tracker is not responding within the given time, then job tracker assigns this T1 task to any of the other. This process we call like speculative execution. What is that? Job tracker assigns task to task tracker. Task tracker need to rest within the given time, called heartbeat time. If task tracker is not responding, then job tracker assigns the task to another task tracker. This process is called speculative execution. Assume. Yes, any query got anyone?
Yeah, so each job tracker also check the health monitoring of task tracker or not?
Yes, yes. See, job tracker responsibilities, four responsibilities, right? So, task assigning, balancing the load balancing. Right, check this right. 1 second. Job tracker responsibilities. Job tracker resides within the master node. Task tracker resides within the slave node. In the notes clearly I have mentioned all this. Number of task trackers depends on number of slave systems. Job tracker responsibilities. Task assignment, assigning the task to the slaves. Load balancing. Fault tolerance mechanism. Fault tolerance means if multiple tasks are executed by multiple slaves, suddenly if any one system goes down, then the task of that will be assigned to any of the other. That we called as fault. Health monitoring also, right? You are just asking about that health monitoring. Yes. Health monitoring, right? Yes. Yes. Before you assign any task to that, first the job tracker will have the health status of each and every task tracker, right? Means each and every slave, the health status is maintained, right? So, and also job tracker has the capability. If I assign a task to the first particular slave, what is the time taken by every slave? Okay, that also it can predict. The health status also, right? Yes. Task tracker responsibilities. Task tracker responsibilities. Executing the tasks given by job tracker. What is task tracker? Executing the tasks given by job tracker. Once task is done, gives acknowledgement to job tracker. Task tracker sends a heartbeat signals to job tracker for every 2 seconds. This task tracker responsibilities. So if we talk about this job tracker and task tracker, right? Yes. If task tracker is not responding, then job track that is called as speculative execution. If this speculative execution, right? Speculative execution. Speculative execution comes into picture only when task tracker is not responding. Speculative execution comes into picture only when task tracker is not responding. If task tracker is responding, and saying that the task is about to be failed, then job tracker asks task tracker to task tracker to retry for 4 times, even after 4 retry attempts. Even after 4 retry attempts, after 4 retry attempts still failed, then the job is termed as even after 4 retry attempts still failed, then the job is termed as failed. Job tracker asks task tracker to retry for even after 4 retry attempts still failed, then the job is termed as failed. We can also increase, right? We can also increase or decrease. We can also increase or decrease the retry attempts.
Sir, one question here. How does this task tracker knows that the job is getting failed?
So so here task, it is responding. For example, I've given a task to you. I'm giving a task to you, right? And I'm giving 1 hour time, or just 3 tasks given to 3 students. 2 students have responding, right? Okay, and they have done the task. But the third student, right? If he is not responding within the 1 hour time, I will give the task to other student. But the student is responding and saying that I'm unable to do, and it's about to be failed. The task will be failed, right? Then I'll ask to retry for 4 times, 4 retry attempts. Even of the 4 retry attempts, then we say that it is failed. So if task tracker unable to perform it, if task tracker is not responding within the given time, then only if it is not responding. If it is responding and saying that it is about to be failed, then it asks task tracker to retry for 4 times. In these 4 retry attempts, if any time, if it is fine, then okay, the job is passed. The task is, otherwise it will be termed as failed. So we can also increase and decrease the retry attempts. We can also increase or decrease the retry attempts. You can say we can increase the retry attempts. We say generally we can also increase the retry attempts. So for increasing this, what we need to do is for increasing the retry attempts. So go to Hadoop installer directory. Go to like mapped-site.xml. There'll be an XML file like this. mapped-site.xml and perform and just open this file. Open this XML file and perform the following configure. See, configuration XML file means opening and closing. Configuration / configuration. Property and name. Property name / name. What is that? Property name and value. Property name, right? Mapped.map.max intervals, but how many? 5. So here by default it is 4. You can increase to 5 or 6. Okay. So this is speculative execution means if task tracker is not responding, right, then job tracker assigns the task to another task tracker. This is speculative execution. What do you mean by speculative job and speculative task in Hadoop? Speculative job or speculative task. Okay.
I have a question here. So
February, yes.
related to memory actually. So sometime like we get that memory exceed error message, like executor memory exceed error. So is that something related to the this task or job?
No, that executor drivers, executors, everything, right?
Yeah,
We see within the Spark level, right? We are going to allocate the memory, otherwise it takes default memory, right?
yeah.
Yes. That we can allocate that memory.
So that
That
is part of Spark or here like
that you see in Spark drivers, executors, everything, right?
okay. Thanks. Yeah.
That I'll discuss what is driver, executors, narrow transformations,
Okay.
wide transformations, stages, tasks. Okay.
Okay. Thank you.
So what do you mean by speculative job and speculative task means, for example, system 1 executing T1 task, S1 executing T1, S2 executing T2, S2 slave 2 executing T2, slave 3 executing T3 task, slave 1 block B1, slave 1 has got B1, B1 B2 block by T2. Slave 3 in slave 3, we have got a B3 block. Executing the B3 block is nothing but a T3. And we have got a S4. S4 also has got a B1 block. S5 also has got B2, S6, B3. See this B1, B2, B3. Again, it is duplicated, replicated in another 3 systems. Means if this system is down, still the B2 data available in SY, right? If S3 system is down, still the data available in system 6, slave 6. Okay. T1, T2, and T3. T1, see, there is a job divided into 3 tasks, T1, T2, and T3. T1 executed by this, T2 executed, T3 by this. This is 94% completed. This T3 task, 82% completed. Assume this T2 task, it is just 4% completed. It is just 4% completed, right? Yes. Now, if three tasks, assume T1, T2, and T3. T1, T2, and if 3 tasks, T1, T2, and T3 are assigned. If 3 tasks, T1, T2, T3 are assigned to 3 slaves. If 3 tasks, T1, T2, T3 are assigned to 3 slaves, S1, S2, and S3. If any one slave performing badly, if any one slave, assume that S2, if any one slave S2 is performing badly, then the task, See, after some 2 minutes, right? This T1 100% done, T3 100% done. T2 is just 5% only. See, still, they cannot keep waiting for the T2 task because already the task completed. Until all the tasks are done, then only the job is completed, right? If any one slave is performing badly, then the task, which task? T2. Then the task T2, right? Then the task T2. Then the task T2 will be assigned to another slave. The task T2 will be assigned to another slave in the background. In the background. To which slave it will be assigned, anyone? Then the task T2 will be assigned to another slave. To which slave it will assign? To any slave, to which slave or to which system it will be assigned?
S5.
S5, right? Why only S5? Why not S6 or S4?
Because it is in that S5 block 2.
Means task 2 is for executing B2 block.
Based
Task
on the availability that you explain the rules, like we'll check for 3-4 checks, will perform, and then it will assign the task.
No. T2 task is for executing B2 block.
Yeah.
B2 block is present in S5. Only S5 can execute it.
Right. Yeah. And
Here
that,
there is no other choice here.
okay.
It means the B2 block has got some 10 lakh records. Executing the 10 lakh records is nothing but assume the T2 task. But if this slave is performing badly, then who should execute it? Means what the job tracker will do? It will assign the task T2 task to another, which one? To S5 only. No
But
other
how
choice.
it will decide, like, so initially only it will assign these, like, these 3 blocks in different slab.
Yes. In such case, you can go with that criteria, right? For that, which task to be given to which slave, you can go with that criteria, as I said.
Correct, yeah.
But here, this task T2 will be assigned to another slave S5 in the background. S5 only because S5 has got B2 block, and the B2 block executing is nothing but T2 task.
So are these things are visible somewhere? How we can know, like, this task is being performed in this particular slab, or this block is under this slab?
So how this execution is happening, right? Internally, I'm discussing.
Okay.
So before we go with the practical part, okay. So I'm just saying that what happens internally, which you are not able to see all these things. So how this processing is happening within this master slave architecture means everything happens in a automatic. We will no need to perform any of this, right? Only thing is you want to divide the file into fixed size blocks. What should be the block size that you need to specify? That's the only thing. You want to divide the file into multiple partitions called blocks. What should be the size of each partition or block that you need to specify, right? And remaining everything, it will only take care of it. Into which slaves everything. Task T2 will be assigned to another slave S5 in the background. And among S2 and S5, among S2 and S5. See, this T2 task is performed by 2 systems, S2 and S5, both are executing in the back. Among S2 and S5, which one executes the task first? Which one executes the task first? Which one executes the task first? That output will be collected. and the other one will be terminated. I have given 3 tasks to 3 students. 2 students already completed the task, but third student is performing very slow. Then what I did, I didn't terminate the task from him, but in the background, I have given the same task to other student, say S5. Among the 2 students, S2 and S5, who completes the task first, I'll collect their output, and the other one I will terminate.
So like all the slave like they will start executing that particular block at the same time. Parallelly, they will be like executing, right? It will not wait for like slave to like if
Yes,
that
yes,
slave is performing badly or
that's the thing, right? Job tracker is dividing the job into tasks T1, T2, and T3. T1 allocated to S1, T2 to S2, T3 to S3. Who allocated job tracker? In job tracker, okay, it comes to know that okay, you got acknowledgement from this first slave and you got acknowledgement from the third slave, but still you didn't get any acknowledgement from slave 2. But when we see that when we see the status of it, it is only 4 or 5%. Then what job tracker does immediately, it will assign that. Then job tracker immediately assigns the task to other slave in the background. So the task T2 is executed by 2 times by S2 and S3. Which one execute the task first? That output will be, and the other one will be terminated, right?
okay. Yeah.
So this process is called as, this process also is called as, this process is called as speculative execution only. This process is called as speculative execution. The job, right, which uses this speculation, the job which uses this speculation is called speculative job. The job which uses this speculation is called speculative job. The task which is duplicated in the background, the job which is duplicated. In the interviews, they ask, what do you mean by speculative execution in Hadoop? What do you mean by speculative job? What do you mean by speculative? You need to clearly understand this. The task which is duplicated in the background. The task which is duplicated in the background is called as speculative task. The job which uses this speculation is called speculative job. The task which is duplicated in the background is called as speculative task. Okay, that's fine. Understood, right? What do you mean by speculative execution? What do you mean by speculative job? What do you mean by speculative task? The task which is duplicated in the background. Which is the task which is duplicated in the background? Yes, try to respond, right? Which task? T2 task. T2 task, right? This system and these 2 systems are executing the same task. The task is duplicated, right? Speculative task. So there are some architectural changes. We have got like Hadoop versions, if you say Hadoop versions. Hadoop 0.x, Hadoop 0.1 version, 1.x version. 2.x and Hadoop 3.x. From 2 version, we call it as like yarn, yet another resource negotiator. In 0 and 1 versions, there were some drawbacks, right? All the drawbacks we have got rectified in from Hadoop 2 version onwards, right? Hadoop 2. So there are some architectural changes from Hadoop 2 onwards, right? Yes. Now, if you see case 1, in the, see here, name node, is running. Name node running, job tracker down. Name node is running, job tracker down means what is that your understanding here? So within this, within the master and slave, right? So within the master node, name node is running, job tracker service is down. What you are able to perform? Name node is running, job tracker down means as name node is running, storage we can perform, job tracker is down, processing we cannot perform, right? Here, we can perform storage. Here we can perform storage. But processing services are down. But processing services are down. We can perform storage, but processing services are down. Here we can perform storage, but processing services are down. Means here partial cluster services are down. Partial cluster services are down. Here partial cluster services are down. If you see this, right? Job tracker to process any file f1.txt. First, job tracker has to request for that file metadata. To whom? Name node. Job tracker to process any file f1.txt. First, job tracker request name node for input file metadata. Once name node provides the metadata information to job tracker divides the job into task T1, T2 and assigns to multiple task track. Here partial cluster services are down. So here we observe the following. Means what you are observing, right? Running jobs will be terminated. New jobs can't be submitted. Because job tracker down. Queued jobs. Queued jobs means waiting. The jobs which are in the waiting. Queued jobs also.
New jobs cannot be submitted.
New jobs cannot be submitted. New jobs cannot be submitted because job tracker down means processing service is down, right? Running jobs will be terminated. Queued jobs, because job tracker down to give the acknowledgement, right? They cannot provide the acknowledgement. The heartbeat signals will be missing. Queued jobs also will be terminated. Okay, that is case 1. Observe this case 2. Observe this case 2, right? Name node down. Name node is down. Job tracker. Name node down, job tracker running. Now try to say here what you can perform, what you cannot perform here. Storage and processing about the storage and
Secondary name node will be activated.
no, assume that okay, name node and job tracker only, right? They are meant for storage and processing.
Here we can
Then
perform the storage only, not processing.
Name node down, job tracker running. Name node is down, job tracker is running. Now here try to say what we can perform, what we cannot perform here.
Blocks. Assigning blocks to the
The secondary, secondary name node will be activated, right? In that case, and
Oh.
we have N1 and N2.
No, generally
file distribution is
name node is down, job tracker running means what is your observation?
file distribution won't be happened.
So storage will happen here.
No.
Forget about secondary name node, only name node and job tracker.
Okay, then
Storage.
file storage will also be filled,
File
right?
FX.
Processing will happen.
Storage is down.
Storage is down, but processing
Processing will not happen.
processing will happen or not, because job tracker is running.
Processing will happen.
right. So processing should not be done, I am thinking,
Reason?
as no records are present.
Yes,
Because
so here no storage. So here both storage and processing. Here both storage and processing is down. Both storage and processing is down. Both storage and processing is down. Here entire cluster is down. Here partial cluster services are down. Here entire cluster is down. Entire cluster is down. Why we cannot perform processing? Why we cannot perform processing here? Why we cannot perform processing here when job tracker is running?
No metadata is there.
Yes, job tracker. Yes, exactly right. Job tracker to process. Job tracker to process. It requires input file metadata. Input file metadata. But metadata available with name node. but metadata available with name node, but name node is down. But name node is down. Job tracker to process, right? It requires input file but metadata available with the name node. But metadata available with the name node, but name node is down. So job tracker cannot process. So here also try to say about these things. So we observe the following. Just try to comment on this. Running jobs will be terminated. Do you think running jobs will be terminated? Here running jobs will be terminated here also. New jobs cannot be submitted. Queued jobs also will be terminated. Here entire cluster is down. We cannot perform any storage and processing in the second case. In the first case, at least storage you can perform. We can perform storage, but processing services are down. Observe this, right? In the first case, name node running, job tracker down. In the second case, name node down, job tracker running. Try to say me about this. Storage. Say me about new jobs. Running jobs. Queued jobs. So here storage, yes. In the first case, right? Yes. New jobs, no. Running jobs, no. Queued jobs, no. We cannot perform. When name node is down means entire cluster is down. No storage, no processing, no. New jobs, no. Running jobs, no. Queued jobs, no. Yes. In case one, partial cluster services down. Partial cluster services are down. In case one, partial cluster services are down. Only processing, storage you can perform, processing unit, right? In case one, partial cluster services are down. In case two, entire cluster services are down. Entire cluster services are down. So here SPOF is at name node. SPOF is at name node. So here SPOF is at name node. What is SPOF? Single point of failure. See, many interview questions from this, right? Single point of failure. What do you mean by here? SPOF is at name node, means SPOF is single point of failure is name node. If name node down, entire cluster is down. But from Hadoop 2.x onwards, from Hadoop 2.x onwards, it is SPOF free architecture. This is SPOF free architecture. Okay, fine. So in the initial versions like Hadoop 0 version, 1 version, what are the drawbacks and how they are rectified in Hadoop 2 version onwards? Right? Yes. See the storage point of view, processing point of view, right? What is that you observed in the previous versions, in the latest, the coming latest versions, right? Yes. Okay, observe here, right? Understood, right? SPOF free architecture from Hadoop 2.x onwards. So generally there are two types of requests. There are two types of requests. Storage request and processing request. We say like storage request and second like processing request. Observe this processing request if you observe first. Processing request. Observe this processing request goes to where this processing request goes to yes. Processing request goes to yes. Processing request goes to whom? Job tracker. And then job tracker requests for what?
Metadata.
Input file metadata to name node. Job tracker processing request goes to job tracker. First one. First, what is the first step it does? Job tracker request for input file metadata to name node. What is the other thing it does? Once metadata is provided, it divides job into task. It divides the job into task. Now step 3. Selecting the appropriate slaves. Appropriate slaves means task trackers. Are selecting the appropriate slaves, task trackers. Selecting the appropriate slaves for executing the task and assigning the task. And assigning the task to respective okay. This is for one job. This is for one job request. This is for one job request. This is for one job request. If 100 processing requests, if 100 processing requests are made parallelly, if 100 processing requests are made, if 100 processing requests are, this is for only one, right? Job tracker request for input for metadata. Once metadata is provided, it divides the job into tasks, selecting the appropriate set for executing the task, assigning the task to respective slaves. If 100 processing requests are made parallelly, then huge burden on job tracker, right?
Yes.
But from Hadoop 2.x onwards, but from Hadoop 2.x onwards, there is no burden. There is no burden as there is no job tracker. Which was replaced by two components. Which was replaced by
Resource manager.
yes, which was replaced by a resource manager. So there is no job tracker which was replaced by resource manager. So here from Hadoop 2.0 there is no burden as there is no which was replaced by actually two components. Which was replaced by two components. First one, resource manager. Resides in master. Resides in slave. Resides in slave. Understand clearly here. For one project manager, fine. For 100 projects, one project manager, huge burden, right? Observe here, for one project manager, okay. But for 100 projects or 1,000 projects, only one project manager, it's too much huge burden, right? Here also the same thing. So what Hadoop has done, which was replaced by two components, resource manager, which resides in the master node, application resides in slave node. If 10 slaves, 10 application masters. If 10 slaves, 10 application masters. One job. One application, one application master. 3 jobs. Assigned to 3 application masters. 10 jobs. Assigned to 10 application masters. Understanding, right? So there is no burden. So here there is no burden. Ten slaves means 10 application masters. So here the job, whatever the job tracker was doing, it was replaced by two components, resource manager and application master. Resource manager, mainly resource manager only we say, resides in the master. Application master resides in the slave node. See, previously what was that? If 100 jobs are submitted parallelly, then huge burden, right? But here, if 100 jobs are there, 100 application masters available to handle them. If 10 jobs, 10 application masters means 10 slaves means 10 application masters. Each job will be handled by one application master. There is no burden here. Yes, that is rectified, right? Understood this. How, what's happening internally, the storage and processing request.
Is task tracker and application master are same, sir?
No, no. Task tracker name changed to node manager. From Hadoop 2 onwards, task tracker renamed as node manager. Node manager. So job tracker, we say it as resource manager. But what is this application master? I'll be discussing in the architecture, right? When I'm discussing yon architecture. But just as of now, what do you mean by job tracker means resource manager? What is task tracker means node manager. So this resource manager and node manager both will be running whenever you start the processing services. As I was showing you, right? How to start storage and how to start processing. I will be showing you all this practically step by step, right? Yes.
So you need to say in previous versions, the slave is used to execute only one job, but in latest versions, the slave can execute multiple
No,
jobs.
no, there was huge burden on job tracker, I was saying. If even 100 jobs also, job tracker only has to divide each and every job into tasks. Only job tracker only need to assign that all the 100 jobs dividing in 100 jobs assigning to multiple task trackers, everything taken care by job tracker only. But here for 100 jobs, 100 application masters are there. They will take the responsibility. 10 jobs, 10 application master, they will take the responsibility.
When you
Previously only job tracker was the only one, right? Which is used to perform all this, right? Yes. Yeah. Any query? Yes.
Yeah, so when you say like application master here and one like task is assigned to a slab, so you mean like a single server, not a rack, right?
Okay. I'll say, right? Okay. This is master. This is master. These are slaves. These are slaves. These are slaves. These are slaves. Slave 1, slave 2, slave 3, slave 4. This is master node. Master and node architecture. That's what resource manager. Resource.
This is completely a single server, Linux server, or like slabs are different server, and this resource manager like master is
Group of systems. What do you mean by cluster? Group of systems connected in a network. If you got 40 systems, in the 39 will be the slaves, one will be the master.
and master one
The
will
master,
be more
only
powerful.
resource manager will be present, right? Within the master. Within the slaves, first application master 1, application master 2, application master 3, application master n. Okay. For
And
how many
all
slaves?
the like all the slave will have the same configuration, or like in
It can have same configuration or different configurations. Means configuration means hardware configuration you are talking, right?
yes, yeah, like
So
RAM,
I'm running, for
CPU,
example, I'm
board.
running something with the 10 systems as of now, 10 nodes cluster. My business has increased, my data is increased, customers are increased, right? I will increase with 10 more. 10 more means tomorrow a new configured systems I'll bring it. I'll add it to the 20 system cycle. Means it doesn't mean that same like old systems I need to bring and add, no, right? Latest systems I'll add it. It doesn't mean that all the slaves should have the same hardware configuration. No, you can have any configuration. That's why we say Hadoop can run on any hardware, commodity hardware. Yes.
And this master node one, it will be like this system will be more powerful, right, as compared to
Yes,
the slave.
yes, as compared to the slaves, it will be more powerful. And here, any job request comes here. Any job request comes here. Just like a resource manager, like. Okay. So here within the slaves, application masters will be the task trackers. Task trackers means what? Node manager 1, node manager 2, node manager 3, node manager n. So just like a resource manager is just like a principal in the college. If any job or if any, for example, any job comes to the principal, he won't do the job. He will assign it to anyone. First, assume that he has assigned to AM2, application master. It's like head of the department. Assume this is like principal. It will immediately assigns that to AM2. Means, for example, any placement drive has to be conducted. Immediately, he will forward to one of AM2. Multiple head of the departments, right, for different branches. And immediately some other job has come. Then immediately you can assign that job to AM3. Any other job comes, again I'll assign that job to AM4. If any other job comes, I'll assign to AM1. But now none of them are free. Now any new job comes, it will be in the waiting state. Now AM2 will be the whole and sole responsibility, right, in executing that particular job. It divides the job into tasks, T1 task, T2 task. T1 it can assign to any of these node managers. T2 also can assign to any node managers and executes it back.
So here you mean to say each slave is connected to each other. Previously that was not the case, right?
No. Previously also, see, everything are interconnected.
Everything is in network only.
Everything are interconnected. What do you
Okay.
mean by cluster? Means group of nodes connected in network, all the 40 systems connected in network. But previously, what was that? Means only the one which is in the master job tracker only was feeling the responsibility for all the jobs. 10 jobs submitted simultaneously. So the job tracker only was taking the responsibility of all the 10 jobs. But here 10 jobs means as the job of job tracker is divided into two. One will be residing at the master, one will be residing at the slave. So it has improved, and it was saying that if 10 jobs, they will be taken by 10 application masters will take the responsibility, which are in the slaves.
Okay. Sir, one
So,
more question.
yes.
The execution happens with respect to licensing, right? So every time, every slave we need to take licensing of the softwares.
So no. Hadoop is open source, no licensing required, right? So most of these products are from Apache products, right? From Apache site, you can get these things, right? And you can download and install this. Hadoop
Okay.
and Spark are open source.
Okay.
The main feature of this, right? I was saying high speed processing, unlimited storage, and open source asset. No licensing required for this. So understood, right? How this is a rectified application. This AM2 divides the job into task, and this T1, T2 task can be, for example, 4 systems are there. B1 block stored here, B2 block stored here. 2 blocks only available. To execute this B1 block is nothing but T1 task. To execute this B2 block is T2 task. So this NM1 and NM2 will be executing parallelly to execute this B1 and B2. And it gives that acknowledgement to AM2. They give acknowledgement to AM2. AM2 give acknowledgement to resource manager once the job is done. Once the job is done, resource manager will allocate the next job to AM2. Understanding, right? More briefly, I will be discussing in this yarn architectural part. Not a problem, right? It's understood, right? So in that latest versions, you got resource manager and application master, multiple jobs, multiple application masters, right? So yes, so next what I do is I'll show you these things practically, right? So I'll be forwarding.
Yes, sir. One question I have here,
Yes.
so we are going to do this in the local server or in any cloud environment?
Yes. So I'll be showing you in the, see this, everything I'll be showing on yarn, right? Yarn on premises. Okay. Yet another resource negotiator, right? With a cluster, right? So I will be providing you this, right? I'll be providing like a 6 GB file. I'll be forwarding to your Google Drives. You are supposed to download that, right? So I'll be showing you like in VMware image. I'll be providing you a VMware image where I have constructed it, and I have downloaded it, installed the entire this products, Hadoop products, and Spark, right? With Python implementation. Okay, this one like Ubuntu VMware f.rar file, and the second one is keys. You will be getting two files. One is rar file, one is keys, a text file, keys.txt file. These two files. Rar file will be of nearly 6 GB. That you need to extract it. How do you extract here? You need to say extract. You need to say extract. You will get two things from this. Whenever you extract it, you will get two things. You will get two things. First one is VMware workstation. And second thing is Ubuntu. So the Linux that I'm using is Ubuntu, right? We have got Linux, CentOS, Red Hat, and Ubuntu. That Linux we are using is Ubuntu, Ubuntu we say. So not a problem if it doesn't have knowledge on Linux. The next session, just before I go. Okay. So first I'll be showing you on these things, right? Later we can just work on that cloud environment, right? Yes, first just understand these things. Later we can just Ubuntu, right? The Ubuntu. Install this VMware workstation that I am provided, right? After installing it, at the last ask for a key. Already I'm providing the keys. Any one of the key, you can add it into it. Install it. And later everything I'll be demonstrating, right? Just you extract it and install this VMware workstation. Later how to perform everything I will demonstrate in the next week. First I'll demonstrate it. So just as everything going in the Linux environment, I will give the knowledge of Linux, basic Linux commands before we go with the practical. We doesn't use any database. Database has got some drawbacks. We are going with a file system called Hadoop distributed file system. As I'll be discussing on Hadoop distributed file system commands are there. Just like Linux commands, we have got HD one by one command in brief. I'll be discussing right in the next session. Next session, everything will go with the practical. Now from here onwards, there won't be any theoretical. Everything I'll be showing you practical step by step, right? Yes. Okay, fine. Just I'll be so before I go, right, for providing these softwares and providing these notes, right? Yes. This entire notes, whatever we discussed, clear notes is available, right? What all we have discussed. These notes, this software, and you will be getting the recorded videos of the sessions to your Google Drives, notes to your mail IDs, software to your Google Drives, and also a WhatsApp group. You will be added to the WhatsApp group, right? So for that, you need to enroll, right? You're supposed to enroll, right? You can just you can see the mails, right? About the payment process and procedures. You'll be getting to your mails. Check your mails and just get enrolled. So you'll be getting the softwares, notes, everything. Okay. So next week, totally we go with the practical part. The timing of this batch will be 6 to 8. Every week it will be from 6 to 8, right? Later, if you want, we will extend by half an hour up to 6 to 8 or 8:30, right?
Sir, where does we get the course content? Basically, we should ping them. Huh?
Course content also, right? You will be forward. You will be getting to mail, payment processors, everything you will be getting to your mails, right? With what mail you have joined the meeting. So you can see the course content here also, right? In the website. This link I'll paste it, right? This link I'll paste it in your chart window. You can copy
So
this.
my question was related to sir Azure environment. Like suppose this Hadoop we are doing, so like can we do it in any cloud environment like in Azure, inside or somewhere? So how different is it from the that Azure Hadoop things compared to this?
I'm coming to it.
Okay.
Yes. So here, okay, whatever and okay, wherever you are doing, right? But the functionalities, the behavior of this, right? Means whenever you're working with Hive, whenever you're working with Hive, whenever you're working with Spark, the Spark related behavior will remain same, right? Spark behavior, Spark APIs, data frames, OTDs, or Hive SQL language, everything that is going to be wherever you're working here or there, right? Yes. So everything, the behavior of that is not going to change. Means here on premises, you are maintaining the cluster, and then if cloud side, right, you are maintaining it. What's 1 second? So I'll be showing you that also at the later. Just first we'll be discussing with this. Later I'll show you like how to work on those things. Okay. So this is the course content, right? HDFS, map reduce for processing, scoop for import and export from databases, right? Yarn architecture, I said resource manager, application master, which I have discussed, node manager, application, many other things are resource scheduler, job history server, and one NoSQL database I'll be discussing, HBase, right? And Hive, for Hive is one data warehouse kind of environment. We have got SQL and PySpark, RTD computations, persistence options, PySpark groupings, aggregations, various actions and transformations, PySpark SQL data frames. In brief, in depth of PySpark, each and every functionalities, APIs, right? And PySpark SQL functions, aggregate functions, window functions, data and timestamp, each and every built-in function in brief, right? Yes. And PySpark external sources, right? With SQL, Spark and Hive integration, MySQL integration, deployment in local and cluster mode. Yes, PySpark applications, drivers, executor stages, building Spark up, deploying Spark applications to cluster and PySpark streaming, right? And the integration with Kafka and a part of machine learning also, like PySpark ML library also supported. I'll give knowledge on it also, right? Yes. So this is two courses combined, like Hadoop and Spark, and a Spark with Python implementation PySpark. Spark with Scala implementation also, like, but these days PySpark is mostly used. Yes. Yeah. Any query you got? Yes.
So you will be covering this in Azure also, right?
No, this is totally on this yarn, right? This everything will goes on yarn architecture.
Okay.
Cluster. Yes, on premises.
But you told right, you will be showing in Azure.
At the last, I'll be showing you, right? At the end of this, I'll be showing you how we can do all these things in that cloud environment also. But whatever, I'll be showing everything on premises.
Okay, so if we learn this, like it will be easy for to learn Azure also, right? These like in Azure
yes.
also we have PySpark and
yes.
Data
The
Lake.
PySpark behavior remains same, right? What all that RTDs, data frames, and various functionalities, whatever we see, each and everything you'll be learning right here about
Which
each and every functionality, right? Yes.
Which
So
cloud
like,
environment?
see here, I'll be showing you, for example, if PySpark, right? I'll be showing you on Azure Databricks.
Okay, yes.
Like I'll be showing you how to run your code in PySpark. I'll be showing you that, right? In Spark environment, I'll be showing you on Azure Databricks, and also I'll be showing you how to run in Jupyter Notebook, and I'll be showing you how to run in this VM image, right? On premises, all that I'll be showing you in different environments, and how to run on Cloudera distributions, right? Where we get all the inbuilt all these things, right? How to download it and how to run this Cloudera distributions. On different environments, I'll show you how to run these things, right? So yes, so get enrolled for this. You can see that payment and process to your mail IDs. Fine. A WhatsApp group also will be created. You will be added to the WhatsApp group. Yes. So next week we go with the practical part. First, I'll go with this Linux commands, because HDFS commands, you need to have some knowledge on this basic line, not the entire Linux, only like to understand this HDFS, like creating directory, creating file, reading a file, deleting a file, renaming, all these things, right? That you need to know, not all these basic commands for running this HDFS. So we have got HDFS commands for storing data. We pull the data from different databases, data sources, right? In HDFS, there won't be any data initially. We'll how to pull the data. Yes, by using a component called scoop and using the and also your knowledge on streaming data, streaming technologies, NoSQL database, right? Now you can see the online team has forwarded a message, a big message you can see, right? Where you can see their contact details, where they can see the payment details they are providing. Yes, and don't forget to send the screenshot of your payment to this online team, DURGASOFT online training@gmail.com. Then only they will forward the link, right? So next week, next Saturday, the link will be changing. You will be getting a new link, right, for everyone. So you can check your mail, and you can also make store this mobile number, right? If anyone has not got the link, you can call to on this number, right? And yes.
Yeah, so like Python also, if we join Python class also, so we'll get some discount, right?
Yes, Python also, yes, right? So people who wants to go for Python tomorrow at 9 o'clock, 9 p.m. in the evening, right? There is a batch starting, okay? Python batch is starting.
That
Right?
will be also like daily or
That is daily batch. Python is a daily batch, right?
daily
So
what time, sir?
daily
9 o'clock?
9 p.m. IST timing, 9 to 10, 9 to 10. Total Python knowledge you will be getting, like Python core and advanced, right? And that means the coding part, programming part. It looks simple, right? So people who are joining this big data, you will get discount on that Python, right? So yes.
Is there any time, any other timing for that Python?
9 to, as of now, evening batch is going on, right? 9 on evening, 9 to 10. But later, after 10 days, there will be a morning batch at 7 a.m. in the morning, 7 a.m. IST.
Okay.
After 10 days, right?
So you are going to
I'll be taking that Python batch, right? And first 1 month, 1.5 months, we are not going to touch any Python. We'll be discussing about all this Hadoop, HDFS, Hive, Scoop, NoSQL, right? Before we go with Spark, right? It takes nearly 1 month. So meanwhile, if you got basic knowledge of, and also before I start with PySpark also, just for some 1-2 sessions like that, I'll be giving the syntaxes of Python also. Fine. Okay. So people who are joining, big data, right? You can say them, right, as 50% discount you can pay off for Python, right? Python, whatever the Python fees, only 50% you can pay for that Python to have knowledge on Python also, right? Okay. So just say that or in the class it was said, if we join for big data, whatever fees for Python, it's only 50% will be paid. You can say them, right? Fine.
So like 14,000 we can pay for both, right?
Okay, you can, yes, you can say 14,000 for both. Okay, fine.
Okay, sir. Yeah, I'll talk to them.
Now you can talk to them, right? Okay, say that sir said it will be only 50% for Python if it is if you take big data also parallelly. Yes.
Okay.
Fine. Okay. Python fees is only like 5,000 for both Python core and advanced, right? Excluding Django, you're not going for web applications.
Right.
So means if 50% means it will be 2.5. Yes. So okay, that's fine. Go to the thread. So everything will be dealt step by step. Sessions will be interactive sessions. You'll be interacting with me, and everything I'll be showing the practicals, right? step by step. Okay. So I'm stopping for now. We'll continue next Saturday, right? 6 p.m.
Saturday, like, so this weekend class will be this big data class will be at 6 o'clock in the evening.
Every Saturday it will be at 6 o'clock to 8 o'clock, 6 to 8 or 8:30 to go. 6 to 8 timing will be fixed. And a new link you will be getting next Saturday, right? Everyone follow that link.
So Sunday also will be the same timing.
Monday also, Sunday also the same timing.
Okay.
So yes, in the evening. Okay.
Sir,
And you will be added into the WhatsApp groups, right? WhatsApp group next Saturday, right? Yes.
Sir, one question. This big data engineer covers the same topics, sir, or what does this big data engineer does basically?
So yes. See, first observe this. Data scientist, right? A typical data scientist should have the knowledge about all this data engineering also, right? First, you are going to bring the data from different data source. What is the typical task done by this data engineer? He has to bring the data from different data sources, from different databases. He has to pull the data into one place, the way it can accommodate the huge data like HDFS. After bringing the data based on some base requirement, based on that business logic, right? You will apply that business logic and process it as per that, right? After processing on that process to results, right? On the process results, you will perform some kind of analysis. Later comes this data scientist. He will just implement some algorithms and he will just predict it. So based on that, based on the results, right? He is going to perform some kind of predictions, data analysis, clusterings, recommendations can be done, right? So next, the data scientist will do what? Recommendations, clusterings, classifications, predictions, all the analysis will be done on that. So that everything, we have got many steps, right? So data pre-processing will be done, data processing will be done, data extraction, everything done by the data engineering. Data extraction, data loading, data processing, and the pre-processing, everything done by this. So for storing and processing, right? So generally, people ask why big data means for data management, data storage and data processing, and this data science for data analysis, predictions, and classifications, clusterings, right? Yes. Yeah.
So we are data engineers, and
Yes.
after the engineers, the data scientist will come.
Yes. Yes.
Okay.
So a typical, if you're a data scientist, right, you need to have the knowledge about all this Hadoop and Spark. If you see in a typical data science course, right, at the last they will see 1 week they discuss on this Hadoop and Spark.
Okay.
But typical now, as of now, they are dependent on these data engineers. But in the coming days, right, they need to have the knowledge about all these extractions, processing, all this, right? Yeah.
Okay.
Sir, one more question I have.
Yes.
Like,
Yes.
Mostly in interview they ask about designing the pipeline, and also will you be covering?
Spark is totally a data flow language, data pipeline. It's a data flow language. So the output of one will be the input to the next row. So he has got RTD's concept and data frames concept. Everything will be discussing the same, right? Data pipelines. So it's a total Spark is a data flow language. So data pipelines. At each pipe, you'll be performing some filtering, grouping, aggregation, sorting, matchings, right?
So that batch processing is also like called the pipeline, right?
So at each pipe, right, the output of one will be the input to the next pipe.
Okay.
Yes. So Apache, we used to have Apache previously in Hadoop.
Mm-hmm.
Is Python course for Hadoop batch is free or we need to pay? Yes, NagoorBabu, right? So it's Python. It's you can go with just you can pay off of the fees for Python, not totally free. If you join for Hadoop, right? This big data, I'm saying, right, you can pay only 50% for the Python. Means just 2,500 is enough to pay, right, for Python. So anyone who are for big data, if you want to go for Python knowledge also, then just 50% of the that's Not for every batches, right? Only for this batch it was given. For all the previous batches, they used to go for total phase of Python, right? Where because we'll be discussing in brief about Python, right? Fine.
Apache Airflow also will be covered, or like uh, for automation kind of like.
So here, no. In Python, I'll be discussing the Python core advanced and the kind of models like plotting model like matplotlib, NumPy model, numerical Python NumPy, and matplotlib and pandas model will be discussed in brief. Pandas, matplotlib, and NumPy. That will be discussed in brief in Python.
Okay.
Okay.
So the, Apache Airflow is a different kind of tool, right? Where we run the jobs and all.
Yes, it's different, right? But at the last, I'll give some knowledge on it.
Okay, sir. Yeah, that would be helpful.
Okay, fine. Okay. So
We are not covering Scala here.
see, Spark is a execution model which can be implemented in 4 languages: Python, Scala, Java, or language. But mostly preferred, Python and Scala are preferred in the market currently. Previously, Scala was used a lot. I used to take a lot of Spark Scala batches. Now I'm taking more PySpark batches, like the big data with the PySpark batches. Previously, like big data, like Hadoop combination with Spark and Scala. Previously, that boom was more on that Spark with Scala, but today, like because of this ML machine learning Python supporting many ML libraries, so mostly like the Python they're preferring. That's why students also asking more for PySpark, and PySpark also has got great boom. So I'm discussing more batches on this PySpark.
Okay.
Yes, fine. So it's a multi-language support. Spark is a multi-language support. Means Python, Java, Scala, and our language. Mostly used are Python and Scala. But the Spark behavior will be the Spark API.
Your voice is breaking, sir.
Spark is an execution model you are implementing in which one you are Python or Scala. Means how to define a variable in Scala and how to define variable in Python. That is going to differ. Functions in Scala and Python. Language fundamentals are going to differ, right? But the processing of the Spark, the RTDs, data frames, everything remains same in both. What all the functions, inbuilt functionalities, APIs, everything remains same in both the languages.
So, sir, one question. Scala, PySpark and Spark are same, or there are two different things?
See, Spark with Python implementation, they say like PySpark.
Okay.
But if you say Spark, only Spark, if you say means by default it is Scala. If you say only Spark means by default it is implemented in Scala. If you say PySpark means it is implemented in Python.
Python means PY they have taken and
PySpark. Spark by default written in Scala language. That's why we say Spark. That we say like with Scala implementation, but PySpark means with Python implementation. So the previously like most of that we used to go with the Spark Scala batches, but now in the industry like PySpark is mostly preferred than Scala.
Okay.
Okay, fine. But only one programming wise, Python looks very simple. They look like normal English statements. Scala, okay, but it is extension to Java, right? Scala is faster than Python because Python is interpretation line by line execution, but Scala, it's like almost extension to Java. It executes the entire code at once. Scala is faster than Python, right? That's except that remaining everything, right? Python advantages is mainly like for ML for machine learning libraries. It has got powerful libraries for these graphs, for ML libs, and for streaming. For all this, it has got powerful libraries Python is providing. That's why like Python is preferred these days. Okay, fine. So okay, okay, thank you all for your time. Thank you, and we'll meet on next Saturday, right?
You will be providing materials, right? The same materials, right, for all the things?
Yeah, clear notes will be there for all this. Whatever I discussed, right? Clear notes with comments.
Okay. Okay.
Okay.
So only after once we enroll for the course, then only we will get the notes, or
So next Saturday onwards, you'll be getting the notes daily basis. Means that day once the class gets completed, you'll be getting the notes and video.
okay.
Video to your Google Drive, notes to your Gmail, right? Yes.
Sir, who knows the shell script? It will be easy for them like to learn Python or
Python or Scala you're talking?
Python. Like I know shell scripting, sir. So how it will be easy for me to learn Python and
Yes, yes. Python is a very simple language. There is no prerequisites for it, right? Anyone can learn Python. It's
okay.
very simple and easy. There is no prerequisites. For learning Java, okay, prerequisites are there, but for learning Python, there is no prerequisites. So
Okay.
yes,
Thanks.
Python looks like normal English statements. And the Python, the main reason why they are not using Java for Spark is very huge codings. So people will start migrating. Previously in Hadoop in the initial days, like mostly Java is preferred implement as the implementation language, where huge codings, where people started migrating to other technologies by seeing the huge codes, right? So later you got Scala language, now you have got Python for implementing, right, with simple statements and syntaxes. Okay, fine. Okay,
Thanks.
so meet you next Saturday, right, at 6 o'clock. So get
Yeah.
enrolled. Yes, fine.
Thanks.